This is a video of the main demonstration shown by the Open Interconnect Consortium at the Consumer Electronics Show in January of 2015. The demo was put together by Intel, Samsung, MediaTek, and Wigwag using their own hardware and commercially available products from a variety of other manufacturers. The demo employs Wi-Fi, Ethernet, Bluetooth, Zigbee, and 6LoWPAN. A number of protocols run over these various transports. A variety of both x86 and ARM-based platforms are employed with a range of operating systems. The entire demo is controlled by a single application running on an Android phone using a single instance of the OIC framework by a single set of simple, consistent APIs. The demo is comprised of 10 different endpoint devices, 2 gateways, 1 Wi-Fi access point, and the Android phone. Some devices use only OIC code to manage comms protocols and transports. Some use no OIC code, and some use a combination. When the application is started, the framework searches for available devices. The name of each device turns green as it is found. The first device is a Belkin Wemo Smart Plug that uses a MediaTek chipset, which MediaTek loaded with custom OIC firmware. It demonstrates a complete OIC end-to-end connection over Wi-Fi. Next, 2 Insteon dimmer switches. Communication with these is via MediaTek's home gateway reference hardware using OIC code to communicate with the controlling app and non-OIC code to communicate with the dimmers. All communication is over Wi-Fi. The communication path is the same when communicating with the Wi-Fi thermostat. You can see the application reading the current temperature of 72 degrees Fahrenheit and then setting the desired temperature to 77. This shows how adding the OIC framework to an existing non-OIC device like a gateway makes it easier for developers to deliver apps and services with broad interoperability. And now another gateway, this time a commercially available product from Wigwag. It took Wigwag just 4 days from starting work with the OIC code to delivering custom gateway software that included the framework. The addition allows the same app using the same APIs we've already seen in action to control both a Philips Hue light bulb and Wigwag's own LED bulb called Filament that uses 6LoWPAN. The Wigwag gateway includes its own 6LoWPAN radio. It uses Philips hardware to bridge from Ethernet to Zigbee. Next up, an Intel Edison development kit running the OIC framework on an x86 version of Yocto. And now the first example of an OIC protocol plugin that allows the OIC framework to communicate directly with non-OIC devices. In this case, using Bluetooth to communicate with the notification function on a 100% production Samsung Gear S watch. Finally, OIC's Group Manager that allows a single API call to affect multiple devices, in this case turning all of the lights in the OIC demo group on and off. On the right you can see an additional light which is plugged into a production Wemo Smart Plug that's being controlled directly by another protocol plugin. To summarize, the OIC framework and protocol plugins make it easy for developers to build applications and services that deliver broad interoperability without them needing to understand the complexities of the underlying transports and protocols. For more information on the Open Interconnect Consortium, go to openinterconnect.org. The associated open source project can be found at iotivity.org. You don't need to be an OIC member to download, use, or contribute to the open source project.